Hi everyone, welcome back to 3.3 Properties of Functions. Today we're going to look at even and odd and symmetry. We're also going to look at intervals of increasing, decreasing, and constant. We're going to look at extrema, which are maxes and mins, and we're going to answer questions related to those. And it's also very important that you, before our next meeting, you make sure you're familiar with the 8 common functions, as we're going to use those for graphing our piecewise functions and also our transformations in 3.5. Okay, so we kind of talked about even and odd before when we looked at symmetry, believe it or not. So they're related. A function is even if you replace all of the x's with negative x and it returns the same function. It's also symmetric to the y-axis. So we looked at that in a prior section. So that's important to know. So even functions are symmetric to y. A function is odd if you replace the x's with negative x's and you returned the opposite of the function you started with. And odd functions are symmetric to the origin. And it's really easy to remember O for odd and O for origin. And also remember O for opposite. So let's take a look at some examples. In this first one here, we've got g of x equals negative 3x squared plus 2. So if I want to know algebraically, is that even or odd? All I'm going to do is replace my x with negative x. So everywhere there's an x, you're going to replace it with a negative x. And you're going to compare your answer to the original function. So remember, order of operations tells us we have to square, do powers first, and then multiply. So negative x squared is positive x squared, times negative 3 just gives me negative 3x squared plus 2. Now compare both of these two functions. Are they the same, or are they opposite, or are they neither? Here they're exactly the same. So that means that this is an even function, which also means it's symmetric to the y-axis. So if I graph that for you, you'll see. If I type in y equals negative 3 x squared plus 2, as you can see, if you were to fold on the y-axis, one side of the graph would match up with the other side. In the next one, in my function h of x, again, you're going to just simply substitute all of your x's with negative x's. So if I cube a negative x, this part here returns a negative x cubed. And then you have a negative times a negative, which is a positive x cubed. And on the bottom, if I square a negative x, I get an x squared. So now compare your answer with the original function. Are they the same? As you can see, they're not. This one had a negative. This one has a positive. And the denominator is exactly the same. So they're opposite each other. One's negative, one's positive. So since they're opposite, they are odd. And when you have an odd function, it's symmetric to the origin. O for odd, O for origin. So if I was to plug in this function so you can look at it, y equals parentheses negative x cubed and then divided by 3x squared minus 9. You can see that it's the same exact function. In fact, if you were to take, your laptop, or if you're watching this on your iPad or whatever, if you take it and turn it upside down, that's the same thing as symmetry to the origin, and it would look exactly the same. The graph would be no different. Okay, so here I give you the graph. You need to determine, is it even, odd, or neither? So again, if you were to take letter A and you were to turn it upside down, which I can kind of show you here. So if I copy and then paste and now turn it, I'm gonna try to turn it anyway, upside down. It does not look the same. So therefore, this is neither. If you take a look at letter B, you can see here that you can fold across the y-axis. So that tells me it's symmetric to the y-axis, which remember also means it's even. So in letter B, you have an even function. Let's look at intervals of increasing, decreasing, and constant intervals. So when you take a look at that graph there, what do you notice about it? What I notice are parts of the graph are going up, you have parts that are going down, and then you have parts that are staying the same, constant. The parts where they're turning are called inflection points. So that's the point where it changes from increasing to decreasing. When we're dealing with intervals, it's always going to be x. So if I take a look at this graph here, okay, let's look at where the intervals are that the graph is increasing and decreasing. So if I look at my graph, right, here's an inflection point because it's going down and then it's going up. So that's where it's changing direction. So where is it increasing? It increases from here to here, and then it starts to decrease. So you're going to look at your x values. It's increasing from -8 to -2. Where else is it increasing? It's increasing from 0 to 2. And it's also increasing from 5 to 7. Okay, where is it decreasing? It's decreasing from, let me get rid of them. It's decreasing from -10 to -8. And it's decreasing from -2 to 0. And from 2 to 5. If you want to know where it's constant, there is no part of that graph that's constant. But if you go back and look at this one, here, constant means it's not changing, right? It's staying the same. So here, the graph would be constant from 0 to 3. Okay, what are some intercepts? So where is it intersecting the x and y axis is what I'm interested in. So here I see an intercept at the following points. There's x-intercepts at -10, 0. Remember, I'm using parentheses now because I'm dealing with ordered pairs. And then I also see a y-intercept at 0, 0 as well. So the x and the y-intercept are both 0, 0. Okay, what's my domain? So my domain would be from this x, -10, to this x, 7. And it's inclusive, right? Because they're closed circles. My range, again, is my lowest y to my highest y. So my lowest y is -4. My highest is 10. Again, inclusive because you have closed circles. Okay, let's look at what we call local max and local min, and the plural is maxima and minima. Sometimes they're referred to as extrema, okay, or extreme values. Think of it as that. We also refer to the word local sometimes as relative. So if you hear a relative max or min, it's the same as a local max or min. And basically, if we were to summarize this, it's any hill, okay, that would be a max, or valley, which would be a min. Points don't count. So if you see just a point on a graph and it's not on a hill or in a valley, it's not considered a max or a min. Absolute max and absolute mins, or also absolute extrema, they would be the overall highest hill, which would be the max, or overall lowest valley, which would be the min. So it's the max or min over the entire function. And there's only one at most. That's why it's the absolute max or min. Okay, so let's look at some examples. So here we have a graph. At what numbers x, if any, does f have a local maximum? List the local maximum values. Okay, so the only local max here is the number 2. So when I ask for maxes and mins, they're the y values. So it's actually 2, and it occurs at x equals 1, right? So when x is 1, y is 2. That's the local max. There actually is no absolute max because the graph goes on forever. As you can see, you have arrows. So there is no absolute max. If the graph had endpoints on it, the only max there is 1, 2. So that would also be considered an absolute max. What about any local minimums? So I see 2 minimums here. I see a minimum and a minimum. So again, the maxes and mins are the y values. So here, one of them is a 1, and it occurs at x equals -1. And then the other one is 3, 0. So that the min would be 0, and it occurs when x is 3. Okay, here's some more examples. So if I look at this graph in letter A, we're looking for first a local max and a local min, right? So all I want here are just the hills and valleys, okay? And remember, points don't count. So the local max here would be 3. And it occurs when x equals 3. So my max is my y value, and my min is my y value. Okay, so do I see any local mins? I see a min right here at 2. Okay, so I've got my min of 2 and my max of 3. Do I have any absolute maxes and absolute mins? No, I don't. I only have local max and local min. I don't have anything to compare the maxes to. There's not 2 maxes, and I can't pick out the highest one. Or there's not 2 mins, and I can't pick out the lowest one. For letter B, do I have any local maxes? So my highest is 3, and it occurs where x equals 2. And my local mins, I have 2. One of them's at 0, the other's at 2. Do I have any absolute maxes? And the answer is no, because it goes on towards infinity. As you can see, there's arrows on the right side. Do I have an absolute min? So I have 2 mins. What's the lowest one? The lowest is 0. Okay, and that ends the lesson for, oh, actually there's one more problem. So for this one, we're looking at a graphing utility to graph the function over the indicated interval. My interval here is -5 to 5. Okay, and that's an open interval. We need to locate any max and any mins. Okay, so I'm going to type this in. So the interval here, when we go to the window, we want to make sure our x min is -5 and our x max is +5. Remember, intervals are x values. Okay, so I'm going to do this on Desmos. And I'm going to type in my function. All right, and I also want to just look at -5 to 5. So for my x-axis, I'm going to change this to -5. And my x-min is 5. Okay, so now just looking from -5 to 5, we want to locate any local maxes and mins. So I see a min here, and my min would be -6.124, and I see another local min there at -3. Of the two mins, which one is the absolute min? It would be the absolute lowest, which would be -6.124. And the only absolute max I see, or I'm sorry, the only local max I see is 5.64. And since there's no other max to compare it to, there is no absolute max. It's just a local max. Okay, so let me write down what we just found there. So my local min is -6.12 and also -3. My absolute min would be the lowest of those two, which would be -6.12. My local max was 5.64. And remember, there is no absolute max because it went on forever on both sides, and I can't compare it to anything. Okay, now that ends 3.3. And make sure you've completed your homework, and if you have any questions, please reach out to me.